Hello, my name is Marcos Morales. I'm a Senior Solution Architect at AWS. Today, I'm going to talk about migrating Windows workloads to AWS. The agenda is going to be common Microsoft workloads migration partners, integrating your Active Directory domain service to AWS, migrating Microsoft SQL Server workloads to AWS, migrating your .NET application to AWS. Then we are going to talk about the end of support migration program for Windows Server, the AWS Migration Acceleration Program, MAP, and AWS Optimization and Licensing Assessment, OLA. So let's get started. If we look at a different perspective for Microsoft workloads, usually we see Active Directory as the identity provider, SQL Server as a back-end database, and .NET applications running on Windows Server. So let's understand how you can integrate your existing Active Directory domain service to AWS. So you have three options to run Active Directory domain services at AWS. The first one is to launch an Amazon EC2 instance and promote this instance to a domain controller. The second one is to use AWS Managed Microsoft AD, which is an Active Directory managed by AWS. And then you can use AD connector if you don't want to have any kind of domain controllers or forest and domain at AWS. So let's start and talking about self-managed Active Directory on EC2. So let's say you have your on-premise data center and you have domain controllers, right? You have your domain and your forest, and you want to extend this existing domain and forest to AWS because you want to avoid manage different domains and forests. So the first thing you need to do is to establish a network connection between your on-premise environment and AWS through a direct connect connection or site-to-site VPN. On the AWS side, you are going to launch two Amazon EC2 instances and promote those Amazon EC2 instances as additional domain controllers from your on-premise domain. Also, you have the option to create new subdomains for your existing domain and forest, or you can create a complete new forest if you want to. The benefit of this pattern here is that you have full control of your Active Directory. It's self-managed, so you are responsible for the operational system and the entire Active Directory, like extend your schema and so on. Also, you can create forests and domain trust of any kind. And it also supports specifically Microsoft workloads and technologies like Microsoft Exchange, which require specific security on the attribute and object layer of Active Directory. Now, let's say you still want to use your on-premise identities to log in on AWS resources. However, you don't want to manage domain controllers at AWS. So what you can do is to use AWS Managed Microsoft AD. The Managed Microsoft AD is going to deploy two domain controllers on different availability zones. The Managed AD is then going to create a new domain in a new forest. With that, you can establish a domain or forest trust relationship between your on-premise Active Directory and the AWS Managed AD. And then you can use one-way or two-way trust or selective authorization. So you can select specific users from your on-premise Active Directory to be able to log in on resources on AWS side. On the AWS side, resources like Amazon EC2 instance, Amazon RDS for SQL Server, Amazon RDS for Oracle, and Amazon RDS for Postgres, and Amazon FSx for the Windows File Server can be a resource with AWS Managed AD. The benefits of using this approach is that AWS manages the infrastructure, the Windows Server, and the Active Directory. So your responsibility is to manage objects within this Active Directory domain. It also supports single sign-on. So you can integrate the AWS Managed AD with the AWS Console and APIs. So at the time you have a trust relationship between your on-premise environment and the AWS Managed AD, you can then use your on-premise identity to log in on the AWS Console and AWS APIs. Also, it has high availability and daily snapshots. And it supports Amazon EC2 seamless domain join. But let's say you don't want to manage domain controllers as Amazon EC2 instance, and you don't want to have additional domain and forest on your Active Directory domain footprint. However, you still want to have direct Active Directory authentication on AWS resources. So what you can do is choose AWS Connector. AWS Connector works as a gateway authentication. So let's say you have Amazon EC2 instance running AWS, and those instances must be part of Active Directory domain. Let's say your on-premise Active Directory domain. However, you don't want to have domain controllers running on AWS. So AD Connector is going to proxy all the directory requests through your VPN or direct connection back to your on-premise Active Directory. Now, let's talk about SQL Server migration partners. You have two options to run SQL Server at AWS. As an Amazon EC2 instance, so you launch Amazon EC2 instance and install your SQL Server, or you can use Amazon RDS for SQL Server, which is the AWS Managed Server. AWS is going to manage the Windows Server and the SQL Server for you. Now, to migrate your on-premise database to AWS, you have three options. The first one, it works on the database level. AWS Database Migration Service, DMS. The second option is to use block-level replication tools like Cloud Endure and AWS Server Migration Service, SMS. And the last option is to use built-in SQL Server tools like distributed availability groups, log shipping, and backup and restore. So let's dig in on those options. So let's say you have an on-premise database. Your source database is going to be a SQL Server 2008 or 2005. And you want to migrate this database to a SQL Server running at AWS on Amazon EC2 or RDS. Using DMS, DMS is going to launch an Amazon EC2 instance called DMS Replication Instance. This instance is going to connect on your source database and in your target database. And the instance is going to handle the replication between those two environments. The DMS also supports CDC, Change Data Capture. So every single change you do in your on-premise database is going to reflect on your target database running at AWS. The benefit of using this solution is that it doesn't require any kind of SQL Server configuration. It's just a matter of authentication on the source database and authentication in the target database. Now, let's say you don't want to connect to the SQL Server at all. You still want to replicate those environments. So you can use a block-level replication approach. In AWS, you can use Cloud Endure. The Cloud Endure is an agent-based solution. So you're going to install the Cloud Endure agent on your SQL Server database on-premise. The agent is going to establish a HTTPS connection with the Cloud Endure console and AWS APIs. The Cloud Endure agent then is going to start capture all the blocks, encrypt those blocks, and compress those blocks and send it to AWS as Amazon EBS volumes. At the time the Cloud Endure finishes the replication, you can access the Cloud Endure web console, and the Cloud Endure can orchestrate Amazon EC2 launch, and is going to attach all those EBS volumes that contains your block replicated from on-premise to this instance, and then you can test your environment. Now, let's say you still want to use block level replication solution, but you cannot have agent-based solution. So you can use SMES, AWS Service Migration Service. With SMES, from AWS Console, you are going to download a virtual appliance and install this virtual appliance on your on-premise hypervisor. Let's say VMware or Hyper-V. From the appliance establishes a HTTPS connection with AWS Console, and from there you can select which virtual machine running on-premise you want to start the replication. So at the time you select a specific virtual machine, let's say your SQL Server database, the SMES virtual appliance is going to capture all the blocks on your on-premise environment and send it as a virtual disk, a VMDK or VAG, to your S3 bucket. Then SMES is going to convert this virtual disk into Amazon EBS snapshot. Then using SMES, you can create a EC2 AMI from those snapshots and launch your EC2 instance. But let's say, you know what, I don't want to use any kind of third-party tool or block level replication or DMS to replicate my database. So you can use native SQL Server tools. And one option, in this example, let's say you have your on-premise environment, you have a SQL Server always on, up and running. So you have your primary replica and your secondary replica. You establish a network connection between on-premise and AWS. At AWS, you set up an availability group running on SQL Server. And you want to migrate database from one availability group, from on-premise, to the AWS availability group. So what you can do is to set up the distributed availability group. The distributed availability group is going to then replicate the database from your primary replica on-premise to your primary replica at AWS. And when you are using distributed availability group, it calls SQL Server Forwarder. In that way, you can leverage SQL Server native tools to replicate your database. Now let's talk about .NET application migration partners. So to migrate a .NET application, you have some options. The first one is to rehost your app. So you can run your .NET application on top of Amazon EC2 instance. This is not going to change the way you build your app or the way you deploy your app. It's going to be the same as you do on-premise. However, if you want to have a re-platform approach, you can use AWS Elastic Beanstalk and deploy your app on top of Amazon EC2 instance, which is managed by the AWS Beanstalk service. Or if you want to containerize your .NET application to run on Windows container, and then the orchestrator for this Windows container can be Amazon Elastic Container Service, ECS, or Amazon Kubernetes Service, Amazon EKS. Or you can even refactor your app to run as a serverless solution on top of AWS Lambda. So let's dig in on the re-platforming options. So the first option here, we create an open source solution called Windows Web Application Migration Assistance for AWS Elastic Beanstalk. This is an open source tool. So you can migrate your .NET application from on-premise to Elastic Beanstalk with minimal to no code change. Developers' productivity is going to grow because there is no need to handle deployments. It's all done by Elastic Beanstalk, and reduction of IT operation overhead because there is no need to manage Windows Server, patching, backup, load balancers. So how it works? So let's say in this example, you have an ASP.NET application running on-premise. You download the open source solution from AWS website, and the solution is based on a PowerShell script. So you run the Migration IaaS website tool, the PowerShell script, and the PowerShell script is going to discover all your IaaS sites which host your ASP.NET application. You are going to then select an IaaS website you want to migrate. The application then is going to discover the connection string And here you have the option to change the connection string. So let's say you already migrate your SQL Server. So you can change the connection string during the migration to point to a SQL Server running on AWS. Then the solution is going to generate a Elastic Beanstalk deployment bundle, which contains all your IaaS configuration and application files. And then you can deploy this app directly on the Elastic Beanstalk container. And inside the container, you have deployments. So you can use roll-up updates, deployment, or A/B testing. So it's quickly and easy. You can move your app from premise to Elastic Beanstalk using our open source solution. The second option of replatforming is when you want to run your ASP.NET application on Windows container. So we created an open source solution called AWS App2Container, which automatically converts your ASP.NET application running on a full Windows server on-premise to a Windows container. Minimal to no code change. So let's see how it works. It takes around 30 minutes to complete the entire migration. So let's take a look how it works. The same example, you have your ASP.NET application running on-premise. You download AWS App2Container from our website. Then you're gonna run your App2Container against your on-premise application server. App2Container is gonna discover and do an inventory of all your IaaS sites, and you can select a specific site you want to containerize. Then App2Container is gonna discover all the dependencies like connection strings. You can update the connection string to point to a SQL Server you already migrate to AWS. So App2Container is gonna extract all the application files and IaaS configurations, and it's gonna upload those artifacts to our Amazon S3 bucket. From there, the App2Container workspace, which is an Amazon EC2 instance that you are going to install App2Container and contains Docker, the App2Container is going to containerize. It's going to create a Windows container image with your app and push it to Amazon ECR, Elastic Container Repository. App2Container then is going to register a ECS task definition. So you can test your application on a Windows container image on ECS cluster. Also, it's going to generate a CloudFormation template to deploy the ECS cluster if you don't have one. But let's say you don't want to use ECS, you want to use EKS. So App2Container generates two manifests, the service and the deploy manifest, and a CloudFormation template to deploy a EKS cluster containing Windows workloads. And then you can test your app. But let's talk about the end of support migration program, EMP. Let's say your app cannot be containerized or cannot be running on Elastic Beanstalk. This app has tightly integration with a specific Windows Server version, like Windows Server 2003. And you want to migrate this app to Windows Server 2019. How to do that? So you can download our open source tool, EMP. Install the open source tool on the application server. The EMP then is going to open the compatibility package. And then you have two options. You can open your application and navigate through your application, and the EMP package is going to intercept all the API calls from the user level and kernel level and create a standalone package, which you can then run it on Windows Server 2019. This is a great option if you don't have the installation media anymore, or people that build this app isn't part of the company anymore. The other option is where you have the installation media. So you open the EMP compatibility package, run the installation media, and you are ready to go. But we're talking about tools and partners. Let's talk now, and migration is a journey, right? So let's talk about the AWS Migration Acceleration Program, MEAP. The MAP is a free program which has 3 phases: the Access, Mobilize, and Migration Modernize. The Access is all about creating a business case. We are going to work with you to build a business case. We are going to train your team with some immersion days and workshops. The Mobilize is where assessment and operation model is going to be created. We are going to train your team to do that. Then you have the Migrate and Modernize, where migration really happens. We are going to work with you to create, operate, optimize, and modernize your apps. And also we have the AWS Optimization License Assessment, which is a program that is going to help you to scope your workloads, to identify workloads that has quick wins on optimization. Then the AWS or AWS APN partner is going to run the migration evaluation tool. It's going to do a collecting data. It's going to run an assessment on your environment. And then the AWS partner or AWS is going to analyze this data with you and generate a plan for migration. The OLA is great because we can identify with you all the license you already have and you already purchased and how you can use it at AWS. To learn more about migration with the AWS Training Certification team. So you have 3 options like virtual trainings. A good one is strategies and tools to perform large-scale migration, 1-hour virtual training. However, if you want to dive deep with classroom training with AWS Expert, you have the Migration to AWS 2 days training. Access the AWS.training and search for migration to learn more. Thank you so much for your time, and please complete the session survey. Your feedback is very important. Thank you.